Good morning, good afternoon, good evening, depending on where you are in the world. Welcome to this session of the Modelling World International Conference. I'm your chair for today. I'm Julie Ballantyne, and I'm with Stantec based in Christchurch, New Zealand. Today, our session is talking about freight modelling, and we have 4 presentations to run through. At the end of these, we will do questions and answers. So if you've got questions, there's a section on the right-hand side where you can type them in. Then I will read them out at the end, and we can have some discussion on how to improve what we do and the positives and negatives of freight modelling. So I'm going to introduce our first speakers now. So we have 2 presenters, so Stephen and David. Stephen is a transport modeller with SMEC and has over 35 years experience. He's based in Perth. David specialises in freight modelling. He's got 38 years of experience, very accurate, David, and he's based in Canada. So if no more from me, I pass to Stephen and David.
Thank you, Julie. I hope everyone can hear me. And I'm going to start off and do the first part of the presentation, and then I'm going to hand over to David, who is going above and beyond the call of duty here today because it's 2 a.m. in Canada where he is. So thank you for joining us, David. So we're going to do a discussion and presentation today about the ATAP Urban Freight Modeling Guidelines. I work for SMEC in Perth. I'm a technical principal, and David is a consultant based in Ottawa, Canada. Next slide, please. So just an overview. I'm going to take you through the key takeaways first, in case we run out of time. So it's important we get to the key messages. Following that, I'll talk about the purpose of the guidelines, introduce the study team and the Austroad Steering Committee. We'll do an overview of urban freight modeling, and then we'll talk about model types, choosing the right type of model, and emerging approaches and future directions. That document on the right side of the screen there is the ATAP guidelines for urban freight modeling, which is to be released fairly shortly. Next slide, please. Next slide. Okay, so there are many planning needs for freight models, and urban freight models are obviously evolving, and they're a bit less common than passenger models. Data is a key issue, and so practitioner guidance is needed. In Australian practice, there are 2 broad approaches. Number 1 is a commodity flow model approach, also called the freight movement model. This is quite a common approach in many Australian capital cities, which translates supply chain flows to urban vehicle trips. Then we also have the trip-based models, which model urban vehicle trips directly. Each approach has advantages, and the choice depends on what you want to use the model for, your city size, and especially data availability. Tour-based formulations and other advancements will improve the state of practice in time. Next slide. So the purpose of the guideline, Transport Assessment and Planning Guidelines, that's what ATAP stands for. It's a comprehensive series of practitioner guidelines that we use in modeling, and you can see the website address there if you want to go and take a look. Urban freight modeling guidelines, obviously less well known than the traditional urban passenger models. And these guidelines describe current and emerging Australian and overseas practice and provide some insight as to the choice of models and the supporting data requirements. And as I mentioned, the guidelines are now being readied for publication. Next slide. This is the ATAP Steering Committee, and that's Dr. Peter Tessato, Dr. Wesley Soet, Kieran Douth, and David Mitchell. Wes is meant to be doing a presentation today. Hopefully he will get in and be able to do that, having a few technical problems, but we'll hopefully resolve those. Next slide. And this is just the study team. This is myself, and David Kriger, and my colleague Richard Eisted, also from SMEC in Perth, who's involved in the project. Next slide. Okay, quick overview of urban freight. Can we go to the next slide? That's fine. Thanks. So this is just a quick geography lesson for those of you who are not in Australia. I'm sure the Kiwis know the Australian geography as well, but as you can see here from the map, we have a variety of different types of models in use at the moment. There are trip-based models used in Adelaide and Hobart. There are commodity flow models used in Melbourne and Brisbane. Trip-based and commodity flow models are used in Perth and Sydney. And Canberra is in the process of developing a new model in the next year or two. Next slide, please. Quick overview about urban freight model. Read for transport economic development, for infrastructure improvements, and many other applications as listed there. In the interest of time, we'll move forward. Next slide, please. So here are the key real issues and opportunities when you're thinking about and planning for urban freight modeling. Data availability is number one. Data has been notoriously difficult to collect and expensive to collect, which is why it isn't done very often. And that's one of the key issues, obviously. In Australia, we have a thing called the National Telematics Framework and National Freight Data Hub, which is an emerging data source for data for urban freight modeling. It's not quite ready for use yet, but in the future it will be. The impact of e-commerce is a big issue, especially on light commercial vehicles and vans and so on, with the explosion in online shopping. Multi-class assignment, light commercial vehicles is a huge issue. It's one of the areas that are quite weak because we don't have enough data, and it's an area that's growing quite rapidly as well, so it's very important. Mode choice is obviously very important, emerging model types, and of course, the COVID-19 pandemic. Next slide. Okay, so we're going to talk about model types, and this is where I'm going to hand over to David.
Okay, thank you, Steve, and hello, everyone. It's a pleasure to be here with you today. So just wanted to, a big part of this guide is really to categorize and define what exactly we're talking about in terms of urban freight models, and was quite surprised to learn that there's a number of different definitions that people use. So starting off here, two broad approaches. One, just for the purposes of this guide, on the left you see in the orange commodity flow models. These are largely, you could say, top-down models where they describe the commodities that are being moved by various modes across a large area, a state, a country, even several countries together. And from these eventually we're trying to get at converting these flows to urban flows and ultimately to urban vehicle trips. So what the advantage of this is that it provides a direct tie to the supply chain, the economic structure. So as an area's economic structure changes, so will the flows change. However, you've got to translate these to urban trips, to vehicle trips, and so that conversion can be aggregate. It does tend to focus, the process tends to focus on the larger vehicles and on long-haul trips as well. On the right side, another approach is the trip or tour-based, also tour-based models. Not quite the same thing, of course, but the point here is that it's looking at the trips, what's actually being moved. So the focus here is on directly down to the urban side on road-based vehicle trips, and it models explicitly the urban itineraries, and ultimately in tour-based models it does it very, very explicitly. So it's capturing the actual stops that are made, function of the land use, and many other factors as well. So again, here the focus is the explicit modeling of vehicle trips so that you can get in greater specificity into understanding of the operational side of things and how trips react to policies and the like. The links with other modes and with supply chains, or broader supply chains, can be more difficult, more discrete, and often can be tied into the intermodal terminals where goods come in by rail, and then it's the vehicle trips that are modeled. It is more adept at capturing different types of vehicles, the smaller, medium-sized vehicles as well, as opposed to the commodity flow approach. So next slide, please. In Australia, just showing here briefly what various of the statewide multimodal commodity flow models look like, and without going into the details on the flow chart, what it's really capturing is all the sectors of the economy of the state and ultimately national economy, what's moving through ports, airports, and again focusing on large commercial vehicles in urban areas, and that's a very large focus. Next slide, please. The trip-based models, again, following a common format for trip-based modeling. Here, however, there's no mode choice because it's all assumed to be vehicle trips, road vehicles. So generation, distribution, and assignment. No tour-based freight models in Australia at the moment. Simple growth factors are also used for smaller applications based on the current traffic mix. Next slide. So how to choose the right type of model, we'll go on to the next slide, please. And various factors to consider, notably, why is this model being used? What do you need as a reasonable proxy? And we're trying to be very practical with this to providing the guidance. How large is the city, again, as a proxy for its economy and its whole economic structure? As Steve mentioned, data availability is key. How much does it cost to build the model? Not trivial. Time frame, when is it needed? And of course, the skilled resources to develop the model. Those are, I think, common questions for modeling generally. Next slide. Putting all this together, come up with a grid. On the left side, you can see city size. And again, these are approximate. And taking into account not only city side, but whether there's special generators, for instance, a port or some very large industry that dominates. And you can see going through the modeling, according to modeling purpose, whether looking at new infrastructure investment or praising different alternative projects or advanced uses, or other uses such as policy assessment. So you can see the different types of models that could formulations that could be used here. And again, ultimately, ideally progressing from commodity-based through trip-based and then eventually to tour-based as those become more and more developed. Next slide. Data, of course, huge issue, a number of different sources, and including employment surveys of what's the economy looking like, what's driving the economy, establishment surveys, what do different establishment businesses produce, what do they do, trip diary surveys of vehicles, the itineraries, roadside surveys, where if you can't get the vehicle itself, the driver to conduct the survey, then pulling vehicles over at the side of the road, often used for at external cordons around an urban area, GPS traces of fleet services, use those, and some of those data may be available. And finally, screen line counts to help in the model calibration. Next slide. And finally, just wanted to take you to bring the presentation to a close, talking about tour-based models. They're not used in Australia yet for freight, but they are coming. Again, generating the entire tour, and on the right you can see a diagram of what a tour looks like. And recognizes that some types of commodities are tied to certain types of land uses and are tied to certain types of vehicles. So it's much more specific operationally. The intermediate stops are added to the tour. And then ultimately all this is brought into an OD matrix for assignment. And finally, the last slide just to close, just to talk about some overseas trends, that is outside Australia, what's happening in other parts of the world. North America, certainly parts of Europe, transitioning from trip-based models to tour-based models, and that's parallel to what's happening with passenger models. Urban commodity flow models are not so commonly used. What is happening is from national flows, the commodity flows are derived from that. Agent-based modeling is starting to take, becoming more common, looking at how different actors behave along the whole line, whether the driver, whether the supplier, whether the purchaser, everybody along the way. The decisions that they make also impact the routes and the itineraries and the like. Looking at the supply chain, how to bring that from the broad picture into local trip choices, establishment survey data, understanding better what's happening, using more and more GPS trace data to leverage establishment surveys against the GPS traces and trip surveys. And finally, looking now at mobile apps and other technologies. Of course, there's a number of issues with those. So that concludes the presentation, and I thank you very much.
David, Stephen, thank you very much. That was extremely informative. Very good to hear some of the decision-making process in choosing your type of freight model. A reminder for everyone, I've jotted my questions down for the session at the end, but if you do have questions, type them into the Q&A panel on the right, and we'll run through them at the end. So now we're going to move to Gerard for his presentation. So Gerard is the Director of Significance and a research professor at the Institute of Transport Studies in Leeds. So he's worked with passenger and freight models nationally, and that'll be in the UK, I'm assuming, Gerard, as well as internationally. So I'll pass to you now.
Okay, thank you very much. Good morning. Good afternoon, good evening, whatever time zone you're in. In my presentation, I'll be going through the main developments in freight transport modeling, at least as I see them, in recent years, and more specifically since the year 2013. So the question that I'll be asking myself in this presentation is, the last 7 years in freight transport modeling, were these 7 fat years or were these 7 lean years? It's based on a literature review that I undertook together with my colleagues at Significance, Michiel de Bok and Sebastian Thun. Next one, please. Then here's an overview of this presentation. After a short introduction, I'll distinguish 2 review papers which are important for this presentation. Then most of the presentation will be about the key developments in freight transport modeling since the year 2013. I'll focus on the state-of-the-art models, but in most cases, this is not art for art's sake. Most of the models I'll be talking about have been developed for transport authorities, and they're being used in practice. And finally, I'll provide some points for discussion. Next one, please. Several researchers have been claiming in the past that freight transport is lagging behind passenger transport modeling. And I think that for a long time, they were absolutely right. Freight transport modeling, well, not much was happening there. And the things that were happening, they were largely borrowing their key concepts from passenger transport. However, since the beginning of this century, since about 2000, things are changing. Freight transport modeling has been receiving more attention, and it has also seen more original development. Not everything that's happening is still coming from passengers. Some things are, for instance, coming from operations research. Next one, please. In this presentation, I'll distinguish 2 review papers. The first I will call the 2013 paper. This is a paper that I wrote together with Inge Viert, Lori Travassi, and Roger Benakiva. It was published in Transportation, and it reviews models, freight transport models at several levels, but mostly within Europe. It concluded that since about 2000, up to 2013, the main development in freight transport modeling was the inclusion of more logistics components in the freight transport model, such as including inventory considerations in the model, so that you get a trade-off between transport cost and inventory cost, which also determines the shipment size. Another example is the use of multimodal transport chains, or the use of consolidation centers and distribution centers. Next one, please. Then the other paper I'll distinguish here is what I call the 2021 paper. It has the same title as the presentation, and there are also these authors I already mentioned. This paper starts from the 2013 paper. The starting point is that between 2000 and 2013, for freight transport modeling, we've had a number of fat years. And then the question is, will the 7 years after this, just as in the biblical story in Egypt, then be lean years? So after the fat years, you get lean years, or are these another series of fat years? Next one, please. Okay, so now I'll be going to follow the 2021 paper in reviewing the key developments as I see them in freight transport modeling. Then the first is actually a continuation of what we already saw before that. That is, further logistic decisions are being included in freight transport modeling. The first example is that supply chain information is included in the model. This happens, for instance, in the US at the national scale, at the state scale, at the level of, for instance, the Chicago metropolitan area, or in the Polaris model, which can be used at the urban and the regional level. It also happens in the Sim Mobility Freight model for Singapore. Next one. This is what I'm talking about when I'm saying supply chain information. We have a receiver, a firm that receives the goods, and this receiver chooses then supplier where the goods are purchased. And this is mainly modeled as a choice model based on utility maximization, and the utility then depends on the characteristics of this receiver, of the decision maker, and of the characteristics of the alternatives, the suppliers. What is their capacity? What is their price? Where are they based? And on the basis of the location, one can determine the transport cost. Next one, please. Another key development since 2013 has been the inclusion of tour formation in the freight transport models. A tour is a series of trips that starts and ends at the same location. And in freight transport, there are two types for these. It could be that there are multiple origins where goods are being picked up in a tour, or there could be multiple destinations. So in a tour, a truck visits several receivers and delivers commodities at these different receivers. Tour formation is included in models in the US, in the Singapore model, but also in a model developed in the Netherlands called MassGT. And these models not only include the formation of these tours, how you combine the trips into a tour, but it also handles the time planning, the scheduling of the tours. Next one, please. On the right-hand side, you see a picture which is similar to what you saw in the previous presentation. This is just an example of a tour, a series of trips where goods in this case are delivered to multiple zones, receivers in multiple zones, and each time the truck becomes a bit emptier, and at the end it has to go back completely empty. And on the left-hand side here is how the tour formation works. It starts from a set of shipments, there's a given set of shipments, and each time there's a decision, will a shipment be included in the tour or not? And there's also the start time of the tour, so the scheduling is included as well. This is tour formation. Next one, please. This Dutch model, MassGT, maybe it's good to go through it. It starts, its study area is the biggest province of the Netherlands, which you see here. It's called Zuid-Holland. In this model, there is a synthesis of the firms in this area. So we make a population of firms, and then on that basis, next one, we simulate the demand for shipments. And then next one. Then for these shipments, there's a choice of distribution channel. Next. And then there's the modeling of the route tours. And once we have these, we can calculate in detail at the link level what the emissions are. And finally, next, We can also calculate the emissions at a more aggregate level. Next one, please. Another key development since 2013 has been a further integration of models. On the one hand, within freight models, so this is an integration of national and intercity models together with urban freight models, so that you not only have the intercity flows, but also the first mile and the last mile in the same model. And this happens in models in the US, but also in this Dutch model, MassGT. And another form of integration, maybe even more interesting, is a further integration of passenger transport models with freight transport models. And this goes beyond the assignment of both the cars and the trucks to a common network, because that's something we've seen already for many years. But this goes further. It includes the possibility that all of the freight transport is demand-led, that it all starts from consumer decisions. And this is very interesting because we have already seen a shift from physical shopping trips to online ordering already before the COVID pandemic. But now with the COVID pandemic and a lot of lockdowns in many countries, online ordering and home deliveries, it has increased enormously. And then it's very good to study both the shopping trips and the home deliveries and the online ordering in a single framework. And that can be done once you have a passenger and freight transport model in an integrated system. Next one, please. This is the system that you then get. At the bottom, you see the final consumer, and the final consumer then goes shopping, either physically or online. And then at some stage, the retailer, where the things are being bought, has to decide on restocking. And this is the trigger to all of the freight flows. So it starts from the consumer, and the consumer initiates freight flows, which go back all the way through the supply chains. This model then also includes the formation of the supply chains between receivers and senders in the form of commodity contracts. So that's what I talked earlier about, the choice of supplier. And then things also need to be transported. And for that, the receivers and senders get into logistic contracts with firms, with carriers that have vehicle fleets and maybe also have distribution and consolidation centers. So here in a single framework, you see an integration of consumption, including shopping, production, inventory, and transport. Next one, please. Some other key developments since 2013. One has been the advance of microsimulation in the freight models. We've already seen some of it. It also means that the starting point of the model then becomes a population of firms, and usually that's a synthetic population based on a firm synthesizer. Next. This picture is a bit older. It comes from a paper that I wrote together with Moshe Ben-Akiva in 2013. It's called the ADA framework. It means aggregate, disaggregate, aggregate. It's a representation of the whole freight model in 3 different submodels, not 4 stages, but only 3. And these are the 3 rectangles in this slide. So the first is for economic activity. That's a model for trade. It's a model explaining the flows between production and consumption. Then the second submodel is for the logistic choices, the trade-off between inventory and transport. And the final submodel is the assignment to the networks. Now, already in 2013, we saw some models that handled the logistic choices, so the component in the middle, in a disaggregate fashion. And the other two models were handled in an aggregate fashion. So it was aggregate, disaggregate, aggregate. Macro, micro, and macro again. But since then, we've been seeing developments that go beyond that. We've been seeing developments where the first component, the trade model, also becomes a disaggregate model. So then we get, instead of ADA, we get DDA. And of course, it's easy to predict that future developments in freight transport modeling might go into microscopic assignment, so that you get ADD, or maybe even completely disaggregate, complete micro-based framework. Next one, please. The final 2 key developments that I would like to mention are that in many freight models nowadays, you see specific attention to calculation of emissions, which of course is very important because freight transport contributes quite a lot to the traffic emissions, both greenhouse gases and local emissions. This, for instance, happens in this MassGT model in the Netherlands. And the final development that I'd like to mention is that you see latent variables being included in the models, so that the freight models become hybrid models with hard variables, such as transport time and transport cost, but also soft variables, such as the attitude of the decision makers towards the environment. All the developments that I mentioned, you see in practical models, but this last one, the latent variables, you mainly see in academic work. You don't see it very much in models that are used in practice. And one of the reasons for that is that it's difficult to think about what the future values should be for these attitudes. It's difficult in forecasting. Next one, please. So to wrap up, to summarize, and also give some points for discussion, I think in recent years, freight transport modeling has been closing or at least reducing the gap with passenger models. People used to say that freight transport was the Cinderella of transport modeling. I think that's no longer true. Though on the other hand, I don't think she's married to the prince yet. Can one say that freight transport modeling is now as sophisticated as passenger transport modeling? Well, it's hard to compare. Also because the topic in freight transport in a number of ways is more complex. For instance, because for the same shipment, there are several decision makers. And also because the data situation in freight transport is often bursting from passengers. Very interesting, I think, is that many of the new developments that we have been seeing in recent years in freight transport modeling have been taking place at the urban level. So before 2013, most of the new developments took place in national or regional transport modeling. And urban models were often rather simple. But in recent years, many of the new developments really take place at the urban level. And finally, I think that for freight, there may not be so many things left that we can still learn from passenger transport modeling. We may have taken everything we could learn from that already and may have to look elsewhere for new things. That concludes my presentation. Thank you very much for your attention.
Thank you, Gerard. Also, very, very interesting points that you've raised there, and I've jotted my questions down. I see we've got some questions appearing in the Q&A panel, so we'll cover those at the end. And very impressed that you've got a biblical story reference into your presentation as well. Next up, we have Wes. So Wes leads transport modelling team in Western Australia. He manages the household travel survey as well as the commercial vehicle surveys. So I'll pass to you now, Wes.
Yes. Right, I can't seem to share my presentation, so I'll ask for the backup plan if we can put my presentation on screen based on the file sent forward previously.
I'll just get that sorted for you now, Wes.
Okay, thank you.
Justin, you able to load for us?
Yeah, he's live. We can hear him now. And Wes, your microphone is live now. We can hear you.
Okay, thank you. Is the presentation up? Sorry, I can't see it. Oh, yes. Great. Thank you very much. So thank you very much. My name is Wes Soet from Main Roads, Western Australia. And this afternoon, I'd just like to share with you about our commercial vehicle survey, which has just commenced February this year. Next slide, please. I'd like to acknowledge the consultant team that's currently implementing the survey on our behalf. That's Ipsos, currently in the field, doing a wonderful job. Currently, there's a team of 22 field workers out in the field visiting establishments to gather the important information. Thank you. Next slide. Just take you through the methodology. Next slide, please. So what we're about in putting the CVS together at a glance is that we're interested in how we're going to select the companies or the establishments that we're going to survey. Important to us was to get a spatial representation of the Perth metropolitan area and also an industry representation as well. For those establishments surveyed, we're interested in establishing their tour and trip generation characteristics. For the next stage of sampling at the vehicle level, looking at identifying the vehicle movements and the routes undertaken by the sampled vehicles. We're also interested in what leaves and enters the Perth metropolitan area through the external cordon, and also the behaviour of special establishments. Ultimately, we're looking to weight the data collector and expand it so that it can be useful for applying into our re-estimation, and ultimately to build a new commercial vehicle model. Next slide, please. So as part of that, in improving our commercial vehicle modelling here in Perth, Western Australia, is that we need to have a better understanding of the tour and trip generation by vehicle class and industry across our metropolitan area, a better understanding of the vehicle behaviours by the vehicle class and industry, and understanding of tour and trip types and purposes that also occur across the metropolitan area. Next slide, please. So at a high level, how have we gone about that? Well, initially, once an establishment has been sampled from our phase 1 of sampling, we undertake a recruitment interview where we interview the establishment about its characteristics, the nature of its business, the number of employees, the vehicle fleet, the type, number and mix. Also, we ask some trip generation information as well. And we're also interested in the relationship between that trip generation and the degree of outsourcing, which we're finding to be quite characteristic, that a lot of firms do not own their own vehicles, and they undertake outsourcing to deliver their goods, say. Once we have that establishment information, it's also used as a basis for a second round of sampling to determine vehicle sampling. Prior to that, for the week after they're selected, we ask for additional information for that week on what's the total kilometres travelled by your vehicle classes over that week, the average stops per day, the percentage of different trip types that you make, whether that's goods movement or service delivery, and the trip purpose. Is it a long haul trip or a point-to-point type trip? Once a vehicle is selected, we put GPS devices in the cabin, and there we're collecting information based on looking at capturing the stops distribution on a temporal basis, also geospatially, and capturing their route selection. And from the driver diary form, we're looking at understanding and collecting the distribution of stop purposes and aspects of stops sequencing, and also capturing the extent of empty running. Next slide, please. This is an overview of the methodology. Essentially, the sampling, as touched upon, is a two-phase sampling methodology, and we needed to undertake a two-phase methodology to better understand the representation, both geospatially and by industry, and of the vehicle mix across the Perth metropolitan area. So the first phase involves sampling parcels of land, which is the sample unit across the metropolitan area, and that's done on a geospatial basis and also by industry type. Once a parcel of land has been identified, every establishment in that parcel undergoes a recruitment interview in person, face-to-face, by a field worker, and we obtain those details that we touched upon, the aspects of the establishment itself, number of employees, the vehicle mix, and aspects of the trip generation. There's a short gap while that's enumerated and analysed to form the basis for the second round of sampling, which is the vehicle sampling, and provided that those establishments are willing to proceed to phase 2, we select based on the vehicle mix available to us, and undertake phase 2, which involves drop off of a survey pack, which includes the GPS logger, which is placed in the cabin for 7 days to record the movement. Also a vehicle form and the driver form as well. And after 7 days, that's picked up. Next slide, please. Just some notes on the sampling. Our sample frame for phase 1 is essentially a census of establishments undertaken by our Department of Planning, where they classify all establishments across the Perth metropolitan area by their geographical distribution, north, south, east, west, inner say, and the industry type. We're of course limited to the industry classification in that census, which is commercial, industrial, public purpose, and recreational spaces. So they're our strata geospatially, and in industry type as well. We've found that a large proportion of establishments do not own their own commercial vehicles, so we've had to adjust the sampling for that. And similarly, vehicle ownership rates are lower in commercial areas. So our adjusted way out of that was we had defined what we call special generator areas, where upon analysis we determined where there's a higher proportion of establishments that actually own the larger type trucks, your rigid vehicles and your articulated vehicles. So we otherwise would have been swamped with just surveying light commercial vehicles, say. And that phase 2 sampling is done to make sure we get a representative vehicle mix in that second phase of establishments. Next slide, please. In that graphic there, I suppose the dark blue grey, they're the areas which we're defining as special generator areas, where it's known to be establishments that own and operate their own heavy vehicle fleets, and they're typically around our Perth airport and the heavy and the industrial areas around that precinct to the south and the north. Next slide, please. And I'll just take you through briefly the materials and the communications that we take the establishment through in undertaking the survey. As we've touched upon, the recruitment survey, we collect aspects of establishments, including their business classification, the number of employees at site, aspects of their vehicle fleet, how many vehicles are managed from that site by vehicle class and vehicle number, and also details on their tour and trip generation, the departures by vehicle class, by the different activities, and similarly their arrivals that happen at that site. Typically an arrival most likely is for future outsourcing. Next slide, please. That's our green, what we call establishment questionnaire, where the respondent will provide details for that week's activity, the number of trips being generated from that site by vehicle type during the week, the trip type and purpose, whether it's a long haul trip that's exiting or entering the metropolitan area, and also provides opportunity for them to provide feedback on aspects of the transport network, and we gather that feedback and circulate that to the relevant parties. Next slide, please. That's our driver form, which captures details of the configuration of the vehicle being surveyed, and also whether they're carrying dangerous or placarded goods or dangerous goods and materials. Next slide. That's the driver survey, which captures details of the stops and the sequencing together with the instructions that we give the driver so that they're more comfortable in knowing what they have to do. Next, please. Communication is important. Provide letters and brochures describing what we're about, why we're doing this, how you were selected, and giving you comfort that we're not going to be abusing your information. Next, please. A detailed document which explains all the steps in the process so that the relevant transport manager isn't lost or doesn't know what's happening next. That's been very useful. Next, please. show cards to help the field workers explain various definitions, vehicle configurations, and geographical extents. Very, very helpful for field workers to communicate effectively to the transport managers. Next, please. Our GPS device, we came up with a pizza box, if you like, configuration where the GPS logger goes in a small pizza box in combination with the battery pack. The idea was that we didn't want to, for that GPS logger to be recharged from the dash and interfere with the electronics of the vehicle. So that's worked quite well without any interference from the technology in the cabin. So battery and logger inside the box, and the driver survey is also in the box with pencil and instructions, and the actual vehicle survey on either side of the box. So it's quite a compact configuration and easy to drop off and pick up. Next, please. Privacy, very important. So we give quite a comprehensive one-pager to make clear up front, this is what we're collecting, this is what we're going to, this is what main roads, it's what we're going to see when we receive that data, and just really putting up front where your data is going to go. So we make that clear, because what we do is obtain express consent. It's not implied. The moment you put that pack in your vehicle, you've agreed that this is what we can do to your data. So up front, saves mucking around later. Next slide, please. And also a little card just to reassure the driver, this is not about catching your movements in real time. We're not looking to fine you or find out what you're up to. So just to give them some reassurance that our intentions are noble. Next, please. And a summary of the survey steps, just so that the transport manager knows what's coming up next, so that they're never in the dark. And that's been very useful as well, keeping that communication going. Next, please. Appointment cards, very important. We need people to trust us to keep our word and arrive on time, so that's important. Next. GPS data, the data collected from the GPS devices is converted into GPS stop files, which we use in combination with the driver survey to narrow down stop purpose. So ultimately we'll have stop files for 7 days for each vehicle surveyed across the network. Thank you. Next. We have real-time live field reporting, so we know what's going on, or the consultant knows what's going on. Next, please. So how are we going? Phase 1, our target was 7,000. We've currently, up to the 9th of April, collected 2,900, which is a good response rate. 64, so that's 64% have engaged from the door knock, so that face-to-face approach is working well. For phase 2, our target ultimately is 900 completes, 1,900 vehicles. So far, we have 360 establishment completes at that phase 2 level, with 750 vehicles in the bank, with 7 days of GPS data. And our retention rate from the moment they're recruited to the end is 33%, which we're happy about. Next, please. So what are our key lessons? Face-to-face recruitment is effective, and it's important in engaging particularly that middle level of transport manager that you need to get the job done. Pilot testing, it's been important to follow the data, find out where the vehicles are, percentages of companies that don't have their own vehicles for a start. There's a prevalence of outsourcing out there, which you have to account for. Vehicle ownership rates are lower in commercial areas, and we had to do more extensive testing in those special generator areas, just to make sure we've got some of the heavy vehicles in the mix. And that last point's incorrect, but what I meant to say there is that the vehicle mix is important in the stage 2 sampling, in helping us choose those vehicles at the next level. And next. Thank you, and I'll stop there. Thank you.
Thank you very much, Wes. We will pick up the questions at the end. It's fantastic to see such a lot of good investment going in and collecting the sort of data we need to support our freight and commercial vehicle modelling. So our final speaker for this evening is Uwe. So Uwe is the Global Director at PTV and an expert in sustainable transport and mobility. So over to you, Uwe.
Thank you, Julie. I hope you can hear me. Thank you, Julie, and the whole team for making this possible and for allowing me to speak here. I want to report or present a project that we're currently doing in another part of the world, not Australia or Europe where you're normally working, but it's in the Middle East. And in fact, we are developing a freight model for the state of Qatar, which is a smaller state. I don't have the geography with me, but perhaps you are aware of where Qatar is. Just try to move on. Okay. So my first slide is about perhaps something that all of you know, but why are we developing a model? We're developing a model for the freight transport because, in fact, there was a master plan going on. So the Qatar Freight Master Plan is currently developed by the National Ministry in Qatar, and the transport model is, of course, supporting this process. So what a model normally should do is, in fact, to represent what is the base year, what is currently going on, support the identification of problems and shortcomings in the current conditions, but more importantly, identify potential solutions. And then if the master plan comes up with scenarios, with strategies, with future development ideas, then to represent this in the model and to identify what are the impacts of these designed or identified strategies. And what is going to be, you don't have to read out the table on the right, so that's very small, but what are the main strategies that will come up from the Qatar Freight Master Plan is, of course, measures and strategies in the area of infrastructure development, policy and regulations, but also technology management and organization. And that is, of course, all that has to be or that the freight transport model has to be capable to represent and to model in order to identify what are the impacts of these strategies on the Qatar freight sector. So that's the purpose. The situation. So this is the geography. So it's a rather let's say medium-sized or even small country in the Middle East. It's a peninsula, and I just have to switch to the other screen. Excuse me. And has some particularities. So first of all, as I said, it's not very big. So the distances in the country are relatively short, especially for domestic freight. It's relatively limited. The predominant origin and destination for freight transport in the country is the ports, of course. There are several ports around basically the eastern and the northern coast of the state of Qatar. And there was an airport, the Hamad International Airport, is well, you see the airport symbol in the map. Is close to the metropolitan area of Doha, which is the capital. There is a few logistic nodes in the country, warehousing, distribution centers that have been set up in the last years and are under development now. And there is an extensive highway network in the country. So the road network is very, very well developed, also based on the Qatar master plan of some 10, 15 years ago. The economy is also very special. So we do have, as probably all of you know, the production of oil and gas. This is the main economic sector in the state of Qatar. But there is other industries. There's mineral-based industries. There's farming and agriculture, and there's dairy industries even in this hot climate. For consumption of freight or of goods, there is specialized souks, mainly in the area of Doha, of the capital. But there's local markets also in the other villages, etc. And of course, there is also logistic facilities. So we have the markets for the final customer. We have warehouses, distribution centers, logistic nodes, and this is basically the very particular situation in the state of Qatar. And what we're doing in the model development is basically looking at different levels of detail of the model area. So of course we focus on the state of Qatar, but we do have two main models, and I will not talk a lot about the first one, which is the long haul and the international freight demand model. So what we do here is basically we have to analyze and understand what are the international traffic flows outside of Qatar that influence Qatar. So that's the origin and destination, the incoming and outgoing flows to the state of Qatar, but also the transit flows through Qatar on the global level. So from all parts of the world to the GCC area, to the Gulf area and the Middle East. This is the external. We have the long distance GCC. So GCC stands for Gulf. Yeah, I don't know it now, but it's the Gulf area. So it's these 6 states that you see here: Saudi Arabia, Oman, UAE, Qatar, Bahrain, and Kuwait. So the long distance freight transport inside this area, inside the GCC area. Both of these are the long haul and international freight demand model, which is part of the model that we are developing. And the second part then is the domestic transport. This is the intercity transport inside Qatar between the different origins, the destinations in the different cities and villages of Qatar, plus the intra-city, so the urban short distance model for the metropolitan area of Doha, which is placed in the east of the country, as you can see on the map. And the modeling pillars that we're using here is mainly, of course, we're using, I think you mentioned this, Julie, that I'm from PDV. So, of course, we're using PDV software, which is the PDV Visum. And we're using the model, which is the module that is the TB Freight, which is, in fact, a tour-based module for freight modeling. Just a few pillars or about the model that we're developing. One major issue is the base year, because originally the project was supposed to have 2020 as the base year, but as we all know, this is not a normal year, or has not been a normal year. So we have to change basically the base year to overcome the pandemic issues of this not being very a normal year. And the idea is to use a combination of 2018, where the best data was available, and combine this with the development in 2021. But as we know, also 2021 is probably not a normal year. We'll have to see. This is still under discussion. However, the forecast years, the forecast horizons is 2025, 2030, 35, and 2050. So it's rather a long-term modeling that we're doing here, because that's in fact the horizon years of the Qatar Freight Master Plan. We're looking at all existing vehicle categories in the country, and we have the different demand components. I already mentioned what is basically the main economic background of the country, but we do have the different components set up into establishment-related freight transport. So that's basically the industrial production. We do have some single traffic generators, which is particular industries like cement and concrete works, quarries, dumps, refineries, but also factories. So there's a number of single traffic generators that, of course, we have to take into account. There is the population-related freight traffic, which is mainly the consumption by the population, but we have to know where the population is and how goods are consumed. And of course, there is a change, as has been mentioned before, also by the pandemic, how and where people shop or get their consumption goods. And finally, of course, there's the construction industry, because Qatar is a rapidly developing country and a lot of construction is going on. The problem with construction is it's not one clear position, but it's moving. So the development the development areas are moving and not staying stable on one side. And of course, we're looking at different logistic systems. That's a small graphic here on the right. The different logistic systems, like being direct transport from a producer or the point of entry, which can be the port, to the consumer, or to have a little bit more, as you see on the right part, a little bit more complex distribution channels through depots and retailers, etc., and distribution centers. And of course, all this has to be represented in the domestic model. One other aspect is, in Qatar, we do already have strategic transport model, and as has been mentioned before, of course, focusing on passenger, because that is what is as our Dutch colleague said, this is what is normally done first. We do a passenger model and then think about freight. And in the existing Qatar strategic transport model, freight is a part. There is a component, but of course, it's just a small component. That's why now this Qatar Freight Master Plan develops a Qatar Freight transport model. And as you can see on the left, the black boxes is basically what is existing. So this is the passenger models. This is the strategic model, but also an ABM model is already existing in Qatar. And the long box on the top, which is the passenger and freight road supply model. This is basically the network models that are, of course, existing in the passenger models, and we are using those, enhancing those in order to be capable to represent also all the needs for the freight transport model. And then what is the new development within this project is the red boxes on the right. So that's basically the tour-based freight demand model as the center of the development. And we do have as on the right the long haul and international freight demand model, which is a separate model. And then there is, of course, the assignment. So this is something that has to be both passenger and freight have to be assigned in a combined way to the same networks, and it's basically a road network at the moment in Qatar. So there's no other mode, domestic mode at the moment, and this is basically using the same networks as for the passenger model. And the model structure is, and of course, we're focusing on the right box, which is the domestic model, the tour-based model. But just short insight also on the left, because that's the start for a lot of transport, freight transport in start or end in the state of Qatar. It's the international and the long haul model. So in the end, what we come up with is the normal 4-step procedure. But it is for the different modes. For the international transport, it's the choice of the mode, and then the choice of the port or the point of entry to the country. And then there is different possibilities. Either it comes in from port, airport, not rail terminal yet, but this will come in the next couple of years or decades. And this will then is an input to the national tour-based model, or even if it's coming in via the land border from Saudi Arabia by truck, the international transport, then this is in fact truck vehicle trips that are coming into the country and are directly implemented into the last step of the tour-based model, which is the multi-class assignment. But this is basically what comes from the international model and flows into our national tour-based model. And the national tour-based model, as you can see on the right, is mainly a 4-step procedure, the general 4-step procedure, starting with the socioeconomic data in the country, with first of all the freight generation, and here we also have as I mentioned, the international freight coming in. Leading to production and consumption of freight and of goods in Qatar, the freight distribution, where we have done the OD matrices for the different commodities, because we're using all the commodities that are used, or consumed or produced in the state of Qatar. We have a tour planning, the vehicle type choice, and finally, with the trips being assigned to the networks together with the passenger trips, and then we have the assignment and the vehicle, the traffic loads on the network. Just to show you, there's different long haul and international freight demand models. I'm not going in detail about that because I think we would be running out of time anyway. But this is one part of the model that I showed you on the previous slide. So that basically delivers the input for the points of entry in the country, state of Qatar. But we have to be aware of these global developments, of global trade, and of the implications to freight traffic flows in the state of Qatar. For the tour-based model in Qatar itself, first of all, we have the intermodal long-distance freight transport, which is in this case rather simplified because, as I said, the country is relatively small. So normally we would have as a key concept that we distinguish a predominant main mode, and then complement this main mode by different feeder modes. And then we have to basically have a mode choice on for the main mode. And if we have developed this intermodal chain, we'll then assign basically all and have identified the different terminals. We will then have in the bi-level approach the assignment of the different parts, the different components or legs of this total trip to the different modes where it's running, for example, on truck or on rail, if that is the feeder modes, in this case for a deep sea trip. And the second part is then the urban freight, which is in fact a tour-based model using the module, the TB Freight module from PDV Visum. And the approach is, of course, similar to passenger models, is generation distribution. But then we have an additional additional step, which is the third step, the tour planning, and also the planning of empty vehicle movements. We have the vehicle type choice, the time distribution, and finally the multi-class assignment. So that is the procedure of the urban tour-based model, which in the state of Qatar basically applies to the metropolitan area of Doha. And of course, we have to do this for all the commodities. So we will identify basically the depots, which can be commercial areas. It can be also the point of entry to the country. And then to define this last chain of distribution of goods inside the country. And we've seen different examples in the previous presentations about typical tours, and I think I have another slide where I show how this works. So basically, we have orders and we have different destinations in the city or the metropolitan areas, and the trips have to be combined in an economic way to have to minimize the tour length and to optimize the efficiency of the tour for the operator, and this has to be calibrated by each industry sector, by each commercial sector, in which could be health, as I said, as is mentioned here above, or it could be logistics. But of course, there is many more sectors that have to be optimized. I think this is just a short example how tour-based works. So basically, we have a depot, which is the start of the tours. We have different destinations which are the consumers or the logistics centers. And the first step is how many, if you do the first trip, how many orders are remaining. If you had done the first trip to this large destination, how many orders are remaining here? What are the costs related to different connecting trips to the other destinations, and as a base of that, you will choose what is the best tour. This is a very, very simple example. The best tour of combining, for example, 2 different destinations to a depot, and whether it's 2 individual trips or if it's a tour-based trip. And this is of course done not just for 2 destinations, but for the whole destinations within the clients or the destinations of one of these depots. The major point is because we are at the start. We are at the start, meaning that we have, of course, designed the modeling structure. But as I said, Qatar is a very, very particular country, and we cannot just copy what has a model from another part of the world, not even from neighboring countries, because it's very specific, more for freight transport than for passenger transport. So of course, we need a lot of data. We need data about the country. And I'm very glad that we had the previous presentation about development of surveys. We are not responsible ourselves for the surveys in this project. It's the partner company who's doing that. But it is very critical because, of course, we need a lot of information about the networks. This is mainly available. Also, the special freight generators, this is available. But basically, the characteristics of freight movement, the tour-based freight behavior, and the data needed for calibration and validation of the model, that is very crucial and that is very important. And we do have, and this is, I think, on the next slide, we do have a number of surveys that are part of the project, not under our responsibility, but they are very, very important. So we saw some of them also already in the previous presentation, but the green ones are basically the ones that relate to calibration and validation of the model. We do, of course, need data or information from the operators. So that is the revealed preference survey and also the stated preference survey, because new technologies are coming in Qatar. The idea is, or the plan is, to have rail connecting Qatar with the neighboring countries, Saudi, but also Bahrain via a causeway. but also to connect the major destinations inside the country by rail. So this is in fact a major change of the situation, and we need an SP survey here. But also very important is what is called the roadside intercept survey. So to in fact stop vehicles, trucks and other freight vehicles on the network with police officers, and to get information on the load, on trip length, on the commodities transported, etc. This is things that have started with pilot surveys for the moment, and the issue is, particularly with the pandemic situation, that it's very, very difficult to get data at this moment in time, and therefore, this is the critical situation for the project. Of course, for the later validation of the model, that's basically the validation, traffic counts, automatic, manual, or also turning moving counts. This is something that is possible. I mean, you just have to put detectors or bring people there to count, but everything that is related to interviews, which is in fact the RP and the SP surveys, plus the roadside interviews, this is what is really critical at the moment, and we hope to find a way out here. We're thinking about mobile phone based applications so that we can more or less overcome this issue. But this is very, very difficult because, as mentioned before, Qatar, as many other states in the world, they are special. They are cannot be compared to any other thing. So you have to have the data from that country more than for passenger modeling in order to be able to set up a proper transport model for the freight movements in the country. So that's, I believe, my last slide. So I said we are at the beginning of the project. Our main concern is the service, that we get the right data for that. But then I think we are capable of developing a very good tour-based transport model, freight transport model for Qatar, including particularly the capital area of Doha, which supports the development of the Qatar Freight Master Plan. Thanks a lot. Thank you for your attention.
Uwe, thank you very much. You've obviously got a very comprehensive modelling framework there. You may need to catch up with Wes afterwards in terms of data collection options, because it sounds like Wes has got some stuff under control. So there's been lots of questions through the Q&A section, so I'm just going to run through them now. Some are directed to individual people, others are a little bit more general. So I'm going to kick off with a question from Peter Davidson. So Gerard, you first, but I think it's a question that a lot of our speakers may want to answer. And so Peter's question is, freight models are generally very constrained by data availability. Given that we struggle to get even basic flow data, how can we get details to understand inventory and supply chains? So Gerard, do you want to answer that one first?
I'll give it a try. It depends a lot how the model actually works, what kind of data you need, because some of these models just use a sort of logistic cost minimization to determine, for instance, the transport chains and the shipment sizes. So they take the transport cost and the inventory cost, and whatever gives the lowest cost solution is chosen, and that needs to be calibrated to rather aggregate data, but you don't need very detailed data at the shipment level. If you want to do econometric estimation, then you need data at the shipment level. And in some countries, there is what is called a commodity flow survey. For instance, the US has something like that. Japan has it, Sweden. That's a survey in which firms give all their shipments, and these firms are shippers. They give all their shipments for a week or 2 weeks. Then, for instance, for the Dutch model, this tool formation model, it was estimated on data from carriers from their own information systems. So these carriers have information systems in which they have records on all the vehicle trips and also how these were included into tours. And these have been handed over to Statistics Netherlands and anonymized, and then they can be used for research. So that was the data that the true model was estimated on. So it depends how the model works. There are possibilities here, and I'm seeing more and more advanced models because I also see more and more possibilities of getting advanced and detailed data. I hope this helps a bit in answering the question.
You've done very well. You've answered another question as well, I think, that Stephen posted about talking about collecting data for your urban freight models in Europe. So I think you've covered some of those off there. So David, there was a question here for you from me, in fact. So I'm the chair. I get I can jump in with my questions. So you talked about how to choose the right type of model, and you mentioned that data availability was key. How much do you think making a choice in the type of model boils down to just what data you get? Is it all about the data?
Okay, thank you. That's a really good question. It's not that it's all about the data, but it's just that the data availability really drives what you're able to do. So what that means is that in some cases that if you may have to use whatever data are available and then build a step-by-step model. In other words, you might start off with something fairly simple and then as you get more data, expand that. So for example, there's some consideration about basically starting off with a particular corridor where you've captured data from roadside surveys, roadside interviews, and so on. And so you've captured just the data, the trips that are moving along that corridor. That helps you build a starter model, let's say, for that corridor. And then the next step is once that's in place, you can broaden that to capture the establishment data in a particular area. Now, I'm being I'm being overly simplistic here, but the idea is that you just build it piece by piece. I know in Toronto and Canada's largest city, metropolitan area, about roughly say 6 million people, a tour-based model was developed there, and it captured a few years ago, and it actually was based on GPS traces. So it tends to capture the larger vehicles and interurban and regional trips, but it's missing the urban travel. So the idea is to start off with those major flows, just because those data are available, and then the next step is going forward is to conduct an establishment survey where you can actually capture the smaller vehicles and then build it that way. So that's a better example than my simplistic corridor.
That's good. Excellent. Thank you. And moving on about smaller vehicles, Wes, we have a question here for you from Lindsay Oxlade. So the question is, how is the travel of courier small parcel freight transport data acquired, particularly in the current situation?
Through the sampling process. So a lot of those companies will be located in those special generator areas where there's a concentration of those transportation courier type companies. So they will be selected as part of that fieldwork process, like in those areas where we know where they're most likely located. We're door knocking on all the establishments in those special areas. So we're looking to capture those through the fieldwork process.
Excellent. Well, while you're talking, we'll maybe move on with another question for you, Wes. So from Stephen Craig, what are the key interventions or potential policies that your data collection or modelling is intended to address?
Essentially what we're looking to do in WA, definitely at main roads, our commercial vehicle model is very outdated. So our main motivation, firstly for ourselves and our Department of Transport, is just to re-estimate our commercial vehicle models, because our last commercial vehicle survey was conducted some time ago. So that's our primary focus, and ultimately looking towards developing a new model. So that aside, I suppose the current major policy initiative that's happening in our metropolitan area is looking at a development of a new port to the south of Fremantle. So once we've been able to incorporate this data into re-estimating our models, I'd imagine it would have a key role in analysing different options for that new port in our southern metropolitan area.
Excellent. It'll be a challenge estimating data for a new port. We look forward to seeing the outcomes. Thank you, Wes. So, Gerard, we have another question here for you. So this is from Kirsten Rupp. So we go out to industry to collect data to build our models. Is there any interest in the reverse? And the reverse being, are industries interested in the outcomes of our models for scheduling?
This was a question for me, I guess.
It was.
Okay. Well, I remember that in the beginning of the new model development in Sweden, the researchers for the national model talked with the freight industry, and they showed their models also to the freight industry. That was maybe 2004, 2005. And then the reaction of the people in the freight industry was, we don't recognize much. The things that we're doing, most of them are not in the models. And what is in these models that you have for the public sector, that's something different than what we do. That was 2004, 2005. I think the situation would be very different, well, rather different now, because since then we've been including lots of things that firms are doing themselves, and we're in public authority models now mimicking the behavior of firms in a way. But I don't think we are at the stage that we can say, well, our scheduling models are now so good, and maybe you can try them at home in your firm. On the other hand, we have information from many firms, so we can say something about under which scenarios it will be busy at certain places. That could be interesting for firms because they don't have the information from all the other firms. So I think there are possibilities. Of course, there are privacy issues that need to be sorted out, but I think there are possibilities because our models may not be as detailed as the models that firms are using for their own scheduling, but we have a greater amount of information because we have all the firms in principle in there, and that may be interesting for them.
Definitely. We're moving away from the simple representation of reality of our model, and they're getting more and more detailed. Thank you for that. So a general question, I'll go to you first, Stephen. You talked about guidelines for freight modelling. What is the biggest weakness that you see in our freight modelling, and how should we be addressing that going forward?
It's a great question, Julie. I think it's obviously data, the data that we collect, that we use to calibrate the models, and in particular, in my opinion, the data for light commercial vehicles. I mean, I think most places have a reasonable handle on heavy commercial vehicles because we have secondary sources of data. We have counts where we can, you know, have some data to validate our heavy commercial vehicle models. But light commercial vehicle models is a slightly different situation because visually you can't tell the difference between a regular car and a light commercial vehicle. Sometimes you can, but not always. And so in many of the Australian capital city models that I'm aware of, one of the weakest parts of the model is the light commercial vehicle model. And so I think it's really important to try to collect better data on light commercial vehicles, as is being done by Main Roads at the moment in WA. So yeah, I think the work that's being done by the WA government is going to be hopefully a model for what other cities in Australia and elsewhere can do. It's expensive, obviously, to collect this kind of data, but on the other hand, the models that we're using we're using to justify billions of dollars of infrastructure. So spending a little bit of money on data collection and model development at the front end, I'm sure all of us as modelers would enthusiastically agree with that. But yeah, I think the data collection is number one. But I'd be interested to hear what others think.
Thank you, Stephen. We've got about 5 more minutes. I've got a few more questions to run through. So maybe I'll go to you, Uwe. What do you see as the biggest weakness in our freight modelling and what we can do about it?
I completely agree with Stephen. So data and data collection, that is the main issue. And we do have a lot of experience in developing freight models. And sometimes, I mean, even outside of the pandemic, we did have interviews and for whatever reason, the questionnaires simply don't come back, or the people don't respond. So there's also a question of commercial interests with the operators and data privacy issues. So in one situation, we had a country, Croatia, in Europe. We got 2 survey forms back out of whatever, several hundreds, and of course you cannot build a model on that. And yeah, to overcome this is difficult. I don't know how to overcome it. I mean, technology is one point. We are thinking about having GPS tracking and giving very simple apps to the drivers so that they can put in very simple information, which doesn't deter them a lot from the normal issues, but getting very low level access to these systems that collect the data more automatically. But yeah, that's the main issue. It's very difficult.
Data, isn't it? It's all about it. We've got a couple of minutes left. I've got 2 questions left. So first one again for you, Gerard. So this is from Philip Sumner. Are there techniques for improving freight modelling based on end customer characteristics when limited commercial data on freight flows is available?
Yes, in my presentation, I discussed demand-led freight models. That means that it's being led from the consumer side. It doesn't mean that all of the commodities are being handled in a demand-led fashion. It distinguishes several supply chains, and some of these are pull chains and some of these are push chains. But for the pull chains, yes, this can be based to a large degree on consumer data. If you would have data on purchases, of course, these data can be collected or exist already to a large degree. You have a very good starting point for a number of commodities for when they will be needed where. So that is a very good alternative source. Of course, it's not enough, but it can be very helpful.
It's never enough, is it? We're never happy.
It's never enough. No, I agree with the data. I can't make bricks without clay.
Cool, thank you. We are running out of time. I've got 2 minutes. I'm told I had to stop on the dot. So I know, Lindsay, you've got a couple of questions there. Some of them I'm not going to get to. But Wes, maybe finally from you, from Lindsay, how do you account for the various heavy vehicle route network restrictions and restrictions this places on mobility?
Oh, you mean in a survey collection? Well, we don't. At the survey
it's more likely, I would have thought, application level in terms of the restrictions on mobility. I suppose it's just having a model that's representative when we're looking at the network restrictions and how we represent that in our models.
Oh, you
Yes.
mean like
Yeah.
network restrictions?
Yeah.
For restricted access vehicles? Yes, I suppose through very crudely, with our simple model at the moment, through link attributes, nominate a link as at the assignment stage. Certain link types cannot be accessed by different vehicle types. So that's how we're doing it brutally at the moment, just through the assignment process and different vehicle types being restricted to different link types.
Brilliant.
That's very crude at the moment.
And you've got a spec
do something more.
And we're spec on the hour and a half, which we were told we had to stay within. So good, concise answer. Thank you, Wes. So wrapping up, to Stephen, to David, to Uwe, to Gerard, and to Wes, thank you very much. And for the people that asked questions and the rest of the participants, thank you very much for joining us on this session on freight modelling. From me, it's over and out.